Okay, let's do it. So, we're multiplying polynomials. That can be a lot of different things, but we're going to start with multiplying binomials. And for that, we have a nice little method we can use that we'll take a look at here. For multiplying binomials, we're going to use this little acronym called FOIL. Maybe some of you have heard of it.
What's a FOIL?
What's a FOIL? That's a great question. I'll list it out here. It basically tells you the order in which to multiply things. It stands for, the F is first, O is outer, I is inner, and L is last. And we'll immediately do an example of that, but I'll let you write it down first.
Thank you.
And y'all are going to do quite a lot of these problems. You'll be able to do it in your sleep.
I can't even dream in my sleep. Good luck with that.
All right, I take it y'all are done writing. Let's take a look at this first example. All right, we're going to multiply 3x plus 2 times x minus 5. I've got a binomial times another binomial. And we have this acronym to help us, but you also just want to remember, you've got to distribute each term to every other term. That is another way of thinking about it.
Does it say multiply?
Yeah.
Oh,
Multiply.
there we go, multiply. All right, y'all, let's take a look here. So if I'm using this acronym, hello, Macy. Have a seat, catch up with us. We just started. You picked a good time to walk in. I'll sign your slip a little later.
Mr. Quiz.
And yes, I'll have you take that quiz later. All right, so if I'm using this acronym, I've got first, so I need to take my first terms and multiply those together. 3x times x, that is just 3x squared. Got to add those exponents together. Yes, we've done this before. Yes, a long time ago. Okay, now you move to the outer term. You need to take this first guy right here and multiply him times this outer term. 3x times minus 5 is negative 15x. Okay, now I'm done with the 3x. I've distributed him to both terms. So now I move to my inner terms. I move to the 2. We'll take him and multiply him times the x. Positive 2 times x, that's just plus 2x.
Yes.
Then lastly, I'll take that 2 and multiply it times the minus 5. That's just minus 10. Beautiful, yes, Brooke, I agree. Now tell me, children, do I have like terms this time?
Yes.
I do, yes. Thankfully not very many, just one more step. Both of these have x's in the middle, so I do got to combine those together. That'll give us 3x squared. And these middle ones, negative 15 plus 2, that's negative 13. And that'll do it. Now, is that so scary?
Yeah. But it's gonna get worse.
It really doesn't get much worse. All right, now it's your turn. Y'all will try. Yes, already.
This would not be hard.
2x minus 1 times 6x plus 2. Take a couple minutes, go, don't waste time. Macy, catch up. You have come in late.
Well, I actually got here on time.
Yeah, me neither.
Was here.
What, Noah?
Paper.
In the car. I didn't want to go on time. I have no idea.
I need more paper.
Oh my god.
Don't help me drive paper though.
I don't know what you're thinking about.
Wait, do I need to multiply?
Good. 12x to the?
2.
There you go. Come on, Lionel, give it a shot.
Wait, do I have to do it in the second one?
Yep. 12x to the what?
Wait, so
Stop copying me.
Oh, same thing? No, you have it there, you just forgot to write the power up. You use the 2 times the 2 to get 4.
Taylor, picture me on this is typing.
Plus 4x.
I got this typing complete on. I was so bad. There was absolutely no extra explaining.
I'm gonna repeat mine. Taylor, bro, stop talking across the room. The square, 2x times 6x is all x to the, right there in the 4, 2x times 2, which is 4x. Good.
Negative 4 isn't
Well, that's the power up.
negative 4.
There you go. Well, that's square.
How bad?
Good.
This, I'm gonna put simple.
Good.
What happened?
Okay. 2x times 6x is 12x to the power of 2. They both have an x in them. That has got x power 1, it's got x power 1, all together. Right here on the 5.
It's just me that like I do.
That's right.
Not quite. 4x is right. Okay, negative 1 times 6x is minus 6x.
Don't do that like I was doing.
You should have. Like at work.
Okay, and the negative 1 times 2 is minus 2. I think you started adding.
Like.
I want to doing that.
That's fine. Yeah, now you combine like terms. Good. Good, that's right.
I didn't think I did. So yeah, I didn't do it.
Missed an x on this guy.
Missed an extra strike.
Negative 1 times 6x is minus 6x.
Oh wait, leave this in there.
2x times 2 is 4x.
Your face
Your other
is
terms are mostly right. You can't go to this.
Did you do that face again? Wait, and then this is minus 4. I didn't see it.
4x minus 6x is minus 2x. And then your minus 2 just carries you. All right, y'all. I've bounced around to enough of you there. Back up on the board. Check your answer if I didn't have time to fully check your work.
May I have your attention? May I have your attention, please? Please dismiss the following students to the cafeteria at this time. Please dismiss the following students to the cafeteria for pictures at this time. Taylor Brooke Crane, Sebastian Dowdy, Maya Godfredson, Isaac Hass-Herman, Carter Eubanks, Judah Hopkins, Jaden Northern, and Felix Hahn. Also, if Mr. Faison could come at this time. Thank you.
All right, y'all, back to it. Not wasting any time here. If we distribute these, 2 times the 6 gives you 12. Right here is the most common mistake I see. You gotta watch out for it. Macy, stop talking. X times x is x to the power of 2. Each of these x's has a 1 as their exponent. You gotta add those together. Thank you, Noah.
Noah.
Okay, when we multiply times this 2, 2x times 2 is plus 4x. And then we multiply this negative 1. Do watch your negatives. That's another really common mistake. Negative 1 times 6x minus 6x. Then negative 1 times 2 is negative 2. Combine the terms in the middle. That gives you 12x squared minus 2x minus 2. May I see questions on that one?
No, I know.
Anybody else? Cool. Let's make them a touch longer.
No.
So you're just gonna keep making them longer and longer, and that's how it's gonna get harder?
Not quite. Not quite. This one will be longer though. Yes,
We're
Emily.
doing this ourselves, or?
This one I'm gonna do, then y'all will try one like it.
Perfect.
So we did a binomial times a binomial. Now we'll do binomial times a trinomial. Alright, we'll do 6a minus 2. And we'll multiply that times 9a squared plus 4a minus 7. I wouldn't even say this is harder. It's just a little more writing. You gotta be a little more careful not to mess up exponents or signs. I guess now would be a good time to bring up your handwriting can be your own worst enemy with this kind of thing. Write neat, go slow.
Oh God.
Why did you choose to use A?
The book likes to swap up the variables.
But
You know,
you still treat it the same.
you still treat it the same, yes, bro. Okay, let's begin our journey here. Use arrows if you struggle with keeping track of this kind of thing. We'll do 6a times 9a squared. All right, 6 times 9, that's going to give us 54. All right, the a times a squared, what you think? Tell me, Simon, what's a times a squared?
A to the third.
A to the third, yes. And now we just continue on in that manner. We'll do 6a times this middle guy. 6 times the 4 gives 24. The a times the a, that gives a squared. Right, one more term to multiply that 6a to. Gotta go all the way to the minus 7. 6a times minus 7, that is minus 42a. Yes, Mason,
Thanks, Richard.
go quickly. Right. You all with me so far? Cool. It doesn't get any crazier now. I'm going to do the exact same thing, but now with the negative 2. The negative 2 multiplies times 9a squared. Negative 2 times 9, that's minus 18. Totally fine, there's no a's here. The a squared will just carry with it. Now negative 2 times positive 4a, that's minus 8a. And then do watch your signs. I hate taking off for this. Right here you got a negative 2 times a negative 7. David, what's negative 2 times negative 7?
14.
Positive 14. Do I put plus or minus?
Plus.
Plus.
You put a negative.
What, bro? Excuse me. What'd you say, bro?
Nothing.
You sure? Yeah. All right, we've multiplied everything through. Now we just need to combine like terms. Let's see, we've got 24a squared here, minus 18 squared here, and we got
6.
this minus 42a and minus 8a.
Yay.
That's not too crazy. The 54a cubed just carries down. Okay, these a squared terms that have to do 24 minus 18, that give you plus 6a squared. Yeah, Emily? And right here, negative 42 minus 8.
Is that homework that we turned in today going in the grade book?
No, probably not, but raise your hand if you have any questions. Continue.
Will my math corrections go in the grade book?
Yes,
Okay.
Simon. That gives you minus 50a, and the 14 carries right down. That'll be our answer.
Oh.
Yes, bro.
What's the grade that you have to get to be like eligible for math corrections?
Anything below a 60.
Oh. Darn.
Miss Jenkins told me that she forgot to put my name. I am supposed to.
Okay, then go on. All right, y'all, questions on this one? It's mostly an exercise in being careful, not making small
How
mistakes.
do we know like when to stop?
When there are no more like terms. It's a good question. Here I've got a to the third, a squared, just a, no a. None of those are like terms anymore. Yes, Noah.
Aren't you always going to come out with lesser variables than what you started off with?
Not 100% sure what you mean.
Something like that.
Alright, let's do it ourselves.
Yes. Now let's do it yourselves. Oh, I guess I need more room. All right, y'all try 2x minus 5 times 3x squared plus x minus 4. And here, I'll write down the answer for this one. This one should give you 6x to the third minus 13x squared minus 23x plus 20. That's just to check your answer. Don't blindly copy it down or I will make fun of you. So yeah, I do want you to write out most of these, but what we're doing next, no, what we're doing next. Yes. There you go.
Oh my gosh. I wrote down the answer and that's the problem.
I will resist the urge to make fun of you.
No, like I didn't mean to. That's why I was so confused. That's the answer was the problem. I'm getting 13 too. I'm getting 13 as well.
It's very possible Mr. Davis made a mistake. Mr. Davis did make a mistake. The only part here does that.
Yeah, I got negative 13.
Yes. I did make a mistake, children. Happens to the best of us. This should be a 13. Yes, Kim?
Is this plus 3x or 2x squared?
2x times 3x squared, 6x to the third.
No.
It'll be a zero.
And what was
Then you asked about 2x times
It
x.
was 20 minus 8.
Where did you get 20?
So what number's in front of the x? A 1. You do 2 times that 1 to get 2. There you go. Yes, London?
I don't know where I got negative 8 from. Or, yeah, but do you... Oh, okay.
Minus 8x squared.
Mr. Davis. Squared?
Yes, bro.
Oh, my mom was trying to I'm assuming Oh, yeah. So my first, it's not clicking to me as a term. It's not clicking to me.
I'm sorry.
Straight up on the
Okay. Just the other, but when you get to the negative 6x, we do add.
You do not. When we're adding and subtracting, the exponent stays. That's a good question.
So that's why I was confused, but it's also.
Blaine, how we doing?
Realistic.
Yeah, you just broke the answer now. It doesn't matter. It just, I want you to do it. It's exactly like what we just did. 2x times this, then times this, then times this.
I like this way better than it was. Me too. It's like easy. I'm not a quiz. I'm not a quiz. Okay.
How we
I
doing?
cannot, I'm gonna take off 50 points.
Good job, bro.
You want that one?
Yes, Emma? All right, I'm going to answer Emma's question, then we're going to move on.
I don't know what I did wrong.
No.
Make sure he drops all those.
Yeah.
He will. Guys, no, he's going to. He's going to. I just want to make sure he's not.
Yeah, she wouldn't get one either. She wouldn't get one
This should be
either.
negative 13x to the second. Is the tenth power of 2. Now we're adding and subtracting.
She lives.
We need to make sure Mr.
Good question, though, Emma. All right, children, back up here. Be quiet.
Yeah, she's supposed to.
Kenley, did you need to see the steps worked out?
Yeah.
All right, let's do it.
Yeah.
I'm going to erase that answer. Okay, 2x times 3x squared, 6x to the third. And Kenley, if you see something where it's like, what the heck, let me know. All right, 2x times x, that's 2x squared. And then 2x times minus 4, minus 8x. Do we agree, Kenley?
Yeah.
Cool. Now we multiply by the minus 5. That's going to give us negative 15x squared. Then times the x, that's going to be minus 5x.
Oh, see, I put like 4x squared.
I think you probably added them on accident.
I don't know.
Do you see why it's minus 5x though?
Or would you do negative 5 times x?
Mm-hmm.
Yeah.
Okay. And then the last one, negative 5 times negative 4 plus 20. Then you combine your like terms, these guys and these guys. And that'll give you your final answer, which I'll write again. 6x cubed minus 13x squared minus 13x plus 20.
Okay.
Okay. Now I do have to give y'all one definition for today. It's not a crazy definition.
Alright.
Okay. The word I'm going to define is conjugates, but it comes at the end, so I'm going to tell you that word now. Two numbers of the form a plus b and a minus b. These are called conjugates of each other. Yes, Emily?
Can you explain that a little bit?
Yes, I will explain that a little. While y'all write the defining features, this is how I think about it. You've got the same variables, a and b in both. The defining feature is that the sign of b is flipped. So with different letters, you would say 2x plus y and 2x minus y are conjugates.
Do they have to be in the same problem?
They have to have the same letters, but with the sign between them flipped.
I don't think you get what I'm saying. I don't know how to explain it, so.
Do they have to be in the same problem?
You can't figure it out there.
Just never mind.
Get back to me if you got another way to say it. Okay, but I gotta define that word because my mental math people, y'all will like this.
Oh, good.
a lot of this multiplying polynomials together, they follow the same kind of patterns, and so we get some nice formulas for stuff that fits a certain pattern.
Can I bathroom?
Yes, Ken. Okay, so all of these are special products of binomials. I will not force you to use these. I'm not a huge mental math guy myself, but these can save a lot of time. And besides, we should investigate why these work. All right, our first one is a product of conjugates. So I have to tell you what that word meant. Now remind me, product, what operation does that refer to?
Multiplication.
Multiplication. So a product of conjugates, okay. I'm going to take these two binomials over here, and we're going to multiply them together. When you multiply conjugates, you always get the same thing, okay? And it gives us a nice formula for this. I'm going to write the answer here, and then we'll investigate it over there. We'll work it out and see why it comes out to this. But yes, every single time, if you've got conjugates, they multiply to a squared minus b squared. That middle term vanishes.
What did you just say?
The middle term vanishes.
Oh.
And we will-
That's not what it sounded like.
Oh,
I was really
okay.
confused.
But we will investigate as to how that happens. You don't have to write this part down, but definitely pay attention. I don't want you to just blindly memorize this formula. If we actually multiply it out like we did our first example, well, let's just see what happens. A times A, that just gives me a squared. A times the minus b, that's just minus ab. I'll pause there momentarily. Questions on those two?
I think I'm seeing it.
You think you're seeing it, Simon? That's good.
Okay, so plus AB and the minus AB, they're gonna cancel, right?
You're getting it, yeah. Okay, we'll continue multiplying through here. I move to the b. B times a, that's just plus ab. And then b times minus b is minus b squared. These two terms in the middle are like terms. One is negative, one is positive. Those cancel right out, and you get a squared minus b squared. Yes, London.
Like when doing that, like knowing me, I'd probably put BA and then I wouldn't see that.
That's fine. You could put BA.
And you can still cancel that out?
Yes. The reason why, London, things are like terms if the letters are the same and the exponents are the same. That's still true if you write it as BA. Yes, Simon.
What if the numbers are different?
What if the numbers are different?
Yes, like there's a number in front of the AB.
Like if it was minus 2AB and plus 2AB?
No, minus 2AB plus like 3AB.
Okay. Minus 2AB plus 3AB. Negative 2 plus 3 is 1, so this is just AB.
But that won't happen because it's always going to be the exact same with the conjugates.
In a vacuum, Simon, like separate from this. That would not happen if you have a product of conjugates.
What?
Brooke, be quiet. Okay, that's the product of conjugates. Now let's see another one here. This one is the square of a sum. All right, if you got a square, what exponent is that? What number? Yes, I see people doing this. Other folks? Somebody must know. Taylor Brooke, what is it?
2.
Yes.
That's EV.
And I'm squaring a sum, okay? So that looks like this. A plus B to the power of 2. this one will always give you a squared plus 2ab plus b squared.
When did we get here?
Who said what?
May, where did 2AB come from?
Where did the 2ab come from? That's a great question. We will investigate that over here. Henley and Preston, stop talking. So yeah, that seems odd that this 2ab is here. Let's see if we can't find out why. Yes, Bethany?
What happened, why can't you distribute?
Do you mean put the 2 on the a and the b?
Yes.
That is a mistake so common, it has its own name. That's called the freshman's dream,
Oh.
because every freshman wishes that worked that way. Doesn't work. You can only distribute an exponent to a product or a quotient. You cannot distribute it to a sum or a difference.
Why?
I'm happy to show you an example at a later time,
At a later
but
time.
yeah, I don't have time
Very interesting.
right now. Okay, let's see why this 2ab is here though. A plus b squared. Okay, something squared means to take that thing, in this case a plus b, and multiply it times itself. That's just the definition of an exponent. If I had a power of 3 here, I'd have another copy of a plus b. Right, now let's multiply through like we did. A times a. Now I think I'll ask people. Emma, what's a times a?
A squared.
A squared.
your name, Emma?
Yeah.
A times b. Kenley, what's a times b?
AB.
AB.
Wow.
Baby girls.
Okay. B times a. Carter, what's b times a?
AB.
AB.
Baby.
And notice I've been forgetting to say these are all positive. That's why we got all these pluses. And then b times b. Anthony, what's b times b?
BB.
B to the power of 2. Yep. And that's where the 2ab comes from. We've got like terms in the middle here. They have a 1 in front of both, so they combine together to 2ab. And that's where the 2 comes from. So I guess one way I could answer your question, Emily, you can't distribute this to each one because you missed the middle term. All right, likewise, the next one, the square of a difference. Same thing, but now we'll have a minus b. A minus b squared. Not much changes here. It looks exactly like this, but instead of a plus here, we have a minus. Be a squared minus 2ab plus b squared. And the way you'd see that, you'd multiply through like we did over there, and you'd get precisely this. I think for the sake of time though, I'll skip that one. So yeah, these can save you a lot of time if you can recognize these patterns. So let's see if we can recognize them.
Wait!
This part you didn't have to write down, Emma. That's really the only part you need.
I don't have to go with my notes.
I'm done. It's okay.
Okay,
Just listen.
this is our last example.
And then we're gonna try it on our own.
And then yes, you'll have lots of practice with this. I'll explain that once we're done, bro.
Do we actually have no homework?
You actually have no homework, yes.
First time in 500 years.
I think for actually the first time.
No, I mean, so for like, this is the first time I've never had homework.
Yeah, no, I'm agreeing with you. I think this is the first time you've never had homework. Okay, this one does have an A, B, and C, because we got to see an example of each of these.
Okay.
All right, so for part A, we got 3y plus 5 times 3y minus 5. That's the ugliest 5 I've ever drawn.
You're great. I don't.
And again, I'm not going to force you guys to use these. You totally could do this the way we've been doing it. You could distribute and then combine my terms, that work out all fine. But these formulas do save quite a lot of time.
So we don't have to memorize these.
You don't have to, but I would highly, highly recommend it. It saves a lot of time.
So are these gonna be on a test that we have to do those like that?
I will not force you to use these now. Okay, I think this one though is pretty clearly a product of conjugates. We've got a 3y and a 5 in both of them. Only difference, the sign between them is different. To really stress the point, I'll copy the form down here. We got a plus b times a minus b.
Wait. Why did you do that?
I'm copying
Wait, why
this.
can't you do it the easy way?
I've already said, Macy, you may do it that way if you like, but these formulas do save a lot of time. But all I did, Macy, was copy this directly under this.
Can you tell me why you're doing it?
To really illustrate the point, this is a product of conjugates. All right, so here's how you would use this. A product of conjugates always multiplies to the first term squared minus the second term squared. Okay, so the super fast way to do this is just take my first term, 3y, square that sucker. I'll have a minus, because we'll always have a minus there. That middle term will always cancel out. And then just square the second term. And I'm writing it out in detail here, but if you memorize it and get good at it, you could do this in your head and write down the answer in like 2 seconds.
Would you like allow that though?
Yes, I would allow that. That's why I'm showing you this. Noah, this is like perfect for you.
That's wild.
Yes, London.
How'd you know
The rest of you, be quiet. Yes, London.
How'd you know to do the negative 5 squared instead of the positive 5 squared? Or like, doesn't matter though?
That's just how the formula works. This minus is part of the formula. The b, always take the positive version.
Okay.
Good question. Okay, now I just have to square both of these, and I'm done. This is going to be 9y squared minus 25.
I did the long way too, it was so fast.
Children. You get multiple ways to do it. That's great.
It is.
Yay.
Did you like Simon falling in the other vlog?
All right, let's see these bottom two here. 3y plus 5 all squared. Notice this is just the square of the sum. Again, I'll copy that underneath. So all I have to do is follow this formula. Very handy. I just square the first term, so 3y, all squared. Can they turn around? You always have this plus 2 as part of it. And I just got to multiply that 2 by my first term and my second term.
Where'd the A go?
It died.
Where did what a go?
Right there.
This one?
No. Smooth. Right there. 2AB.
In this?
Uh-huh.
This is just a formula, Mason.
Well, yeah, so how did you get the formula and pull it over? You know, don't you think we would have another letter? That's what the formula is. Maybe.
In this problem, a is 3y, b is 5. So instead of a, b here, I've got 3y and 5. Our last term here, the b squared, that would just be plus 5 squared. And again, once you get used to that, you could do it in your head.
That's a lot harder than what I have.
I promise you, it's not. But this very quickly simplifies to 9y squared plus, let's see, 6 times 5, 30y, plus 25.
No, I definitely
I like the original way better.
If you like the original way better, that's great.
It's how I understand it better, so.
That's fine. That is totally fine. But this can save you quite a lot of time. Yes, Emily?
I changed my question. I don't have a question anymore.
All right, the last one, y'all, goes really, really quick. Tell me, oh, I don't know. Tell me, Noah. What's the only thing that's different between these two formulas?
The plus 2ab,
Exactly, yeah. I've got a plus 2ab here and a minus 2ab here. So,
AB.
if we change this to 3y minus 5 all squared, literally, the answer is as simple as changing that from plus 30y to minus 30y.
AB is trash.
And that falls directly out.
They say AB is in part of the negative column, just as in the bottom line.
And yeah, those are your special products.
Wait.
The last one's my favorite.
The last one is your favorite?
No, I said it was because it's just the simplest.
Pro tips on way to memorize these two, the differences between them. Square of a sum has all sums in it. Square of a difference is exactly the same, just with one minus sign. But yes, that is enough out of me. Now it is time for y'all to practice. I hope I hit record. I did.